Welcome back to our Hard Math with Kevin series. I'm here with Kevin Mabe, the Chief Analytics Officer at Corus. I'm heading into this one blind, Kevin, so I don't know what we're going to be discussing today. I'll just turn it over to you.
This will be good. This will be good. Yeah, so what we're going to discuss today are the dangers and pitfalls of univariate analysis. And what we mean by univariate analysis is taking a look at just one metric and then coming up to conclusions based on that. And so this example will hopefully show how deeper analysis is not only important, but absolutely critical to understanding what's going on. So what I'm going to do is show you some data here. We took two surveys. There's a first wave and a second wave, each with 60 respondents. They were given to three groups of individuals, A, B, and C. We captured their age, and then they rated a satisfaction in a product from basically 1 to 100. And so what I'm going to do is show you the average satisfaction between both surveys. So I'm just going to calculate that real quick. And I'll even show the median as well, which is basically the middle value. So, Drew, what do you see here for the satisfaction, the average and the median from the first wave to the second wave?
Well, it looks like there hasn't been a huge jump in the average, but it does look like in the second wave there were probably a lot of individuals at the higher end of the spectrum, with the median being at 77.
Yep, so we see a few things from here, is that satisfaction did increase, and we did make a policy change between the first and the second wave, and so management would want to look at this and say, hey, did our policy change help satisfaction? So you don't see much of a change with the mean. You do see a bit more of a change with the median. Pardon me. So based on this, a lot of people would say, okay, well, our policy change worked. You know, it's not a big increase for the average, but the policy looks like it increased satisfaction. However, let's start digging into this a bit. So what I'm going to do is take the average and break that out a bit by putting confidence intervals around. Actually, let's actually put the confidence around with that. There we go. Okay. So now what do you see? You see that, you know, satisfaction has in fact increased, but
there's some overlap in those confidence intervals.
Exactly. And so as a result, you know, it doesn't appear that it's all that statistically significant. And in fact, we can actually basically test that and see, you know, is in fact higher or lower. And, you know, the p-value is 0.06, which means it's somewhat statistically significantly higher, but it's not huge compelling evidence. So
Sure.
Now we're going from saying, well, we had an increase in satisfaction to, well, we may have had an increase in satisfaction, but it doesn't appear that it was all that statistically significant. And I'm basically
it could have been anything that drove it, right?
Exactly.
Not necessarily sure.
Exactly. So what I'd like to do is take a look at the samples that that we actually collected here. So I'm going to do a quick pie chart of the three customer types here. All right. So A, B, and C, and again, this is a very quick and dirty visual. But what do you notice between the first wave and the second wave regarding the makeup of who's answering the respondent questions?
Well, obviously there's a huge decline in C and there's a big increase in A.
Okay, that's very good. Awesome.
B goes down a little bit, but not the same.
Right. Well, exactly, and we can actually, test to see, is that distribution statistically significantly different? Because one of the assumptions that we have going into comparing survey after survey after survey is that the makeup of such a sample is pretty much the same. So let's do a quick analysis of that. And this p-value basically says, hey, by the way, these samples are statistically different. So Drew, what you called out regarding the representation of C going down and the representation of A going up is not only directionally correct, it's also statistically correct. Now what I'd like to do is take a look at satisfaction once again, except instead of splitting it by survey, I'm going to split it by this group of A, B, and C. And let's get rid of some of this other nonsense. All right. So between the both surveys, what do you notice about the satisfaction levels of these three customer groups?
Wow. It's very, very dependent on the group that they're in to look at their satisfaction
Correct.
numbers.
Correct.
Obviously, the least satisfied, and,
yep.
and A is the most satisfied.
All right. So now what I'm going to do is, so knowing that, let's put 2 and 2 together here. So we know that A's satisfaction is far higher than B or C. We know that the second wave had an overrepresentation statistically compared to first wave, and C had an underrepresentation statistically to first wave. So couple that together, what that means is that the overall satisfaction that we see all up for survey wave 2 may appear higher than otherwise, simply because we've got an overrepresentation of A and an underrepresentation of C, because we have more of these people. Now you can imagine this is somewhat of a contrived example, but this is much more real world than I think people realize, because this is exactly what gets reported without taking a look at what's underneath. Now, we're taking a look at just group, but we also have age in here, and in other satisfaction surveys, you may have another 12 columns to take a look at. So what we're going to do is basically build an all-up regression to try to understand and answer the business question: did satisfaction decrease between the second and the first wave? So we're going to do continuous predictors, categorical, and again, this is Minitab. You can use any statistical software. This is actually a very basic analysis. So here's the regression table, and it gives you an idea of the impacts of certain things like age, the group or the customer group, and the survey. So I'm going to jump to the punchline here. This survey is statistically significant, and what this regression table basically says is that the second wave is statistically lower than the first wave. So all else equal, and what I mean by that is that controlling for age and controlling for customer group, satisfaction actually not only declined from the first to the second wave, but it is statistically significant. And in fact, the impact is about 4.6 points. And so even though we saw all up that the average increased about that much, what this analysis basically says, not only did it decrease by about that much, but it was statistically significant. And you'll see in the rest of the table that group A has far higher satisfaction than group C. We saw that visually as well. That's also highly statistically significant. And age plays some part of it. It's a very minor effect, but the older the age, the more satisfaction that was given. And so this is basically an analysis to show, and this is a very simple example again, but where we start with the supposition that satisfaction increased, but the actual real answer is that no, not only did it not increase, but it decreased, and in a statistically significant manner. So you can imagine going in front of your management group, Drew, that say when they see these numbers and you basically said, well, not only is there not anything to celebrate, but we have to dig into what the problem is.
Yeah, we're not doing the right things to solve it. That's interesting.
Exactly.
Yeah, I think any of these where it looks like, it looks like you've done your homework in the first step. It looks like you did the survey and you asked the questions and you're looking at them side by side. It looks like you've done all the right work, but you've left a lot on the table, and in many cases you're informing the wrong decision. So
yeah, exactly.
Really cool.
And one other thing, when we talked about the these top line metrics of the average of 60 and average of 65 for the second wave and the median, et cetera. These are statistics, and statistics is, a measurement of these kinds of numbers. But this is not analysis. Analysis is trying to understand, first of all, do I believe what I'm seeing here? What's behind these numbers, and then what's driving those numbers. And so analysis, true analysis is understanding, is this real? And if it's not real, then what else is going on? And that's kind of everything else that we did throughout this video. And I think that's quite a bit of a difference, because when someone says, I analyzed satisfaction, that term is thrown around, when in fact what they did is they took a look at two metrics and said it went up. That just doesn't suffice.
Yeah. Well, that's great, Kevin. Thank you. Thank you as always. This is interesting stuff. Really appreciate it.
Awesome. Thanks again, Drew.